We're now going to look at maximum and minimum problems, example 5. It says a wooden door is to be constructed in the shape of a rectangle surmounted by a semicircle with radius r meters below. The vertical sides of the rectangle are h meters and the perimeter of the door is 8 meters. Part A, show that the area of the door is given by this equation. You'll note that the equation we're trying to show, there's only two variables in it, the subject variable A and the other variable R. You'll note that there's no h in the equation. So we will end up setting up an equation with A, R and h in it, and we're going to have to get rid of h. Okay, so part A, let's start by getting an equation for the area of the door. So area of door so that's equal to the area of the rectangle. So if we take the rectangle here, the length is going to be 2r and the breadth is going to be h. So we're going to be multiplying those together. So the area of the rectangle is going to be 2rh. And then we're going to add on the area of the semicircle. So the area of a circle is pi r squared. But we just want half of that, so it's going to be a half multiplied by pi r squared. Okay, let's tidy it up. So we're going to get A, area of door, is equal to 2RH plus a half pi r squared. Now, here's the problem. The equation that we have, yeah, it's got A, it's got R, but it's also got H. The equation we want to get doesn't have h, so we're going to have to eliminate h somehow. So we have to get rid of h. In other words, we need to set up another equation with h in it. Now, if we go back to the information in the question, there's one thing we haven't used. It says up above here that the perimeter of the door is 8 meters. So let's set up an equation for the perimeter of the door. So, perimeter of door so that's all the edges added together. So if we go back to the diagram, we've got h plus, we've got the bottom bit here, which is twice the radius, 2r, plus the other vertical side, h, and then plus the curved bit. So the curved bit is half the circumference of a circle, so that's going to be a half multiplied by 2 pi r. Okay, let's tidy up. The perimeter of the door, we're told, is 8 meters. So sub in 8 and then tidy up. So h plus h is going to give us 2h. And then we've got plus 2r. And then plus half and 2 cancel, plus pi r. So you see now we've got an equation with h and r in it. What I'm going to do now is make h the subject, because remember, we want to get rid of h. So in other words, we want to make h the subject of the second equation, so it'll all be in terms of r, and then we're going to sub that into the area equation to get rid of h. So let's make h the subject here. So we're going to get 8 subtract 2r subtract pi r is equal to 2h. Okay, let's divide through by the coefficient of h, which is 2. So we'll divide by 2. So we're going to end up with 4 minus r minus pi r over 2, and that's just equal to h. Now I'm going to call this equation 2. I'm going to call the original area equation equation 1. And what we're going to do is we're going to sub this expression for h into equation 1. So we're going to sub 2 into 1. So let's see what happens. So we're going to get a equals 2r, and then in brackets chuck in h, so 4 minus r minus pi r over 2, and then we're adding on a half pi r squared. So it's looking better already because you see now we don't have any h in it. So let's tidy up. We're going to get a equals 8r minus 2r squared minus the 2's cancel, one's in the top, one's in the bottom, so we're going to get minus pi r squared plus a half pi r squared. Okay, so next plan. What we're going to do here is look at where we're trying to get to. We're trying to get to this 8r and then minus, and then in brackets 2 plus pi r, 2 plus pi over 2 all multiplied by r squared. So the good news is we've already got 8r. We've got minus 2r squared. These are like terms, so minus pi r squared plus a half pi r squared is going to be minus a half pi r squared. Okay, now we're going to copy down the 8r. We're going to lift out minus r squared, just like what we have. So we're going to lift out a minus, and then open brackets, and then we're going to lift out r squared as well, just on the other side. That's all I'm doing. I'm just trying to get it in the same form as what we're asked to show. So what do we need to multiply minus r squared by to get minus 2r squared? Well, it's just going to be plus 2. And then what do we need to multiply minus r squared by in order to get minus a half pi r squared? Well, it's going to have to be plus a half pi, or plus pi over 2. Just checking. Minus r squared multiplied by positive pi over 2 is going to give us minus pi over 2r squared. In other words, minus a half pi r squared. And then take a look at what we have. Take a look at where we're trying to go, and you'll discover we have exactly completed part A. We've shown part A correctly. So that was much harder than the previous examples. Okay, they weren't guiding you. They weren't saying, look, set up an equation for h, and then set up an equation for a, and then eliminate h. You were having to do that all yourself. Okay, so that's part A. Okay, part B then says, use calculus to find the exact value of r for which a has a stationary value, and show that this value of r gives a maximum value of a. So a has its stationary value, in other words turning point, when the first derivative is equal to 0. Okay, because at a turning point the subject variable has either its maximum or its minimum value. Okay, so part B, we are going to have to differentiate. We're going to have to work out dA by dr. Just have a wee look at the equation with a and r in it. It's already good to go. It's already good to differentiate, so we don't have to bring r to the top line or anything. So what I'm going to do is differentiate first. So dA by dr. So I'm going to use the version that hasn't been factorized. So differentiate with respect to r, we'll just get 8. Differentiate minus 2r squared, we're going to get minus 4r. Remember, pi is just a number, so if we differentiate all of this term, we multiply it by the power of r. So minus a half times 2 is just going to be minus 1. So we're just going to get minus pi, and then copy down r, and then subtract 1 from the power. So we just got minus pi r to the power of 1. Okay, so next bit. A has its maximum or minimum value when dA by dr is equal to 0. Max or min value means stationary value, same thing. So we're going to set dA by dr equal to 0, so 8 minus 4r minus pi r equals 0. Now just bear in mind at this stage it says find the exact value of r for which a has its maximum or minimum value. The exact value of r. So when we solve this equation we're going to have to keep pi in it. So plan then. What we're going to do is I am going to move the two terms that contain r to the same side. So we're going to get 8 equals 4r plus pi r. I'm now going to factorize the right hand side. So we're going to get 8 equals r upon 4 plus pi. Do you see the way now after factorizing there's only a single r? We're now going to divide both sides by the coefficient of r. So 8 over 4 plus pi is equal to r. So we found the exact value of the other variable which makes the subject variable a maximum or a minimum. So this is the critical value for the other variable. Now, what we're going to do is then prove whether A is a max or a min. So we're going to sub the critical value into the equation for A. So if we go back to part B, show that the value of R gives a maximum value of A. So we're going to prove that A is a maximum. So prove that A is a maximum. So we need d2a by dr squared. We need the second derivative. Okay, so d2a by dr squared. So we go back to the first derivative. There's our first derivative, so we're going to differentiate again with respect to r. So if we do that, we're going to end up with just minus 4 minus pi. So that's going to give us minus 4 minus pi. Now, normally we would sub the critical value in to get the sign of the second derivative, whether it's bigger than 0 or less than 0, but there is no r here to sub in, which is possible sometimes. We've met this before. So minus 4 minus pi is just less than 0. So therefore, A, the area of this door, A is a maximum when r takes the critical value. Okay, so answer A has its maximum value when r is equal to, and again, critical value for r was 8 over 4 plus pi. And obviously r will be in meters, okay, because we were told that in the question. So there's part B. Okay, let's look at part C. Part C then says, find the exact maximum area of the door. So what we're going to do now is sub the critical value of R that makes the area maximum. So we're going to sub the critical value of R into the equation for the area. So part C, maximum area so when R equals 8 over 4 plus pi, we're going to chuck it into the equation for A. So A equals, so we're going to get 8 times R. So I'm going to open brackets, that's 8 times 8 over 4 plus pi. And then minus, open brackets, 2 plus pi over 2. And then we're multiplying that by R squared, so that's going to be 8 over 4 plus pi. And that's all squared. Okay, now let's tidy it up. Multiply out first bracket, that's going to be 64 over 4 plus pi. Copy down our minus. We're going to copy down our 2 plus pi over 2 in brackets. What I'm now going to do is I'm going to square this bracket, so that's going to give us 64 over 4 plus pi all squared. Now I'm not going to multiply out this bracket on the bottom, I'm going to keep the power of 2 because you're going to see now that we're going to end up essentially with two fractions, and I want to make the denominators the same obviously to tidy it up, so keep 4 plus pi in brackets all squared. I'm now going to multiply the 64 over 4 plus pi all squared by the 2 plus pi over 2. So we're going to end up with 64 over 4 plus pi, and then keep our minus here. And then what I'm going to have to do, because there's a minus here, I'm going to open new brackets, and then I'm going to multiply each term in this bracket by 64 over 4 plus pi all squared. So 2 multiplied by this fraction is going to give us 128 over 4 plus pi all squared. And then we're going to multiply pi over 2 by 64 over 4 plus pi all squared. The 2 cancels with the 64, so we're going to end up with plus 32 pi all over 4 plus pi all squared. Okay. The good news is all the denominators are nearly the same, so we need to make this 4 plus pi the same as 4 plus pi all squared. So we're going to multiply this first fraction top and bottom by 4 plus pi. So we're going to get 64 over 4 plus pi, and then we're going to multiply that top and bottom by 4 plus pi, we're now also going to multiply this bracket out by a minus, so that's going to give us minus 128 over 4 plus pi all squared, and then multiply this second fraction by the minus. Minus times plus is minus, and we're going to have 32 pi all over 4 plus pi all squared. Now all of the denominators are the same, so we're going to write it as a single fraction. So we're going to have 64 upon 4 plus pi minus 128 minus 32 pi, and that's all over 4 plus pi all squared. Okay, multiplied the brackets in the top line, so we've got 64 multiplied by 4 is going to give us 256 plus 64 pi minus 128 minus 32 pi, and again that's all over 4 plus pi all squared. Tidy up our numerator then. So we've got 256 subtract 128 is going to give us 128. 64 pi minus 32 pi is just plus 32 pi. And then that's all over 4 plus pi all squared. Now, can we factorize the numerator here? Because if we can, you never know, we might get a 4 plus pi in brackets and then we could cancel. What about if we lifted out 32? Does 32 go into 128? It does. It goes in 4 times. So if I lift out a factor of 32 in the top, so we've got 32 upon 4 plus pi, and that's all over 4 plus pi all squared. So you can see now that we can cancel a 4 plus pi on the top with one of the 4 plus pi's in the bottom, because remember, everything's factorized, pluses and minuses are inside brackets. So let's do the cancelling. Cancel 4 plus pi on the top with a 4 plus pi on the bottom, so we're just left with a single 4 plus pi. So the area, the maximum area of this door is going to be 32 over 4 plus pi, and that's going to be meters squared. And that's your final answer. Again, keep your answer exact because it's said to do so. Keep pi in it.